We have the body fat percentage for a sample of 22 individuals who are members of a gym. So member 1 had 12.6% body fat, member 2 had 6.9% body fat, and so on. And we should make a note of the member number is arbitrary. And what I mean by that is the first person they chose, member 1, could have just as easily been a body fat of 20 rather than 12.6. Okay, so the fact that member 1 had 12.6% body fat, there wasn't a process involved to identify member 1 as having to be the first person they chose. Where you would really want to pay attention to member 1 having 12.6% body fat would be if you were doing a match pairs design where you were doing maybe a before and after. So maybe when they joined the gym, this was this member's body fat percentage, and then after 6 months at the gym, maybe do a after calculation of body fat. Then you would want to make sure that member 1 was paired up with their data. In this example, I could have just as easily not given you the member number and just said, here are 22 individuals who are members of a gym and their body fat percentage. Okay, so first example, or the first question, says construct a histogram and a Box-and-Whisker plot using technology. Okay, so what I did, you go to Stat, and then Enter to edit your list. And this goes along with what I was just saying, that the body fat percentage is the only real variable involved here. So you don't put member number 1, number 2, number 3, and so on in list 1, and body fat percentage in list 2. That's just a waste of time. So your body fat percentage is the variable, so just put that in list 1. To construct a histogram and a Box-and-Whisker using technology, okay, the way you do that, you go to second y equals, and this should be review. So I'm going to go through this quickly. Make sure your plot 1 is on. And then use your arrow to go down to whatever display you want for the histogram. There's the bar chart. I'll choose that one. Your X list is list 1. Frequency is 1, just saying that each of the values only counts once. And then if I do zoom 9 for zoom stat, I'll get a frequency histogram. Now you may want to play around with the window. Okay, this just uses calculates it itself. But if you don't want to start at 5.1, you could say start at 5. And I actually did this on an answer key just to save time. So I put the X minimum to be 5 rather than 5.1, just to start at a nicer number. And then the X maximum, I just said, let's go to 30, because I think 20.8 or something like that was, 28.1 was the highest value. So I just said, let's go to 30. And then if you play around with the scale a little bit, if you use a very small scale, like a scale of, say, 2, if you graph that, notice what's going to happen. You're going to have a large number of bars. There's some missing in there, which is not wrong. It's just, I would say, too many intervals for this example, because there's only 22 data values. So if I go back to my window, and let's just say I make that 4 instead. Well, I have a total distance here of 30 minus 5 is 25. If I go by 4 in each interval, that should give me about 6 or 7 bars. Okay, so now if I graph that, there's 1, 2, 3, 4, 5, 6 bars showing up. So then when you trace it, it says the X minimum 5, maximum less than 9. So that first bar has 4 data values in it, and it'll include any data value between 5 and 9, not including 9 though. So technically up to 8.9999. And then the next interval will include any data value from 9 to 12.99999. And there's 4 data values in that. Okay, as far as the Box-and-Whisker plot, Again, go to your second y equals to go to your stat plot. Now we'll just change this using our arrow key over to the Box-and-Whisker plot. X list is list 1, frequency is 1 again. So now if I graph it with zoom 9, it'll give me the Box-and-Whisker plot. And what's nice about this, when you press trace, it'll give you the minimum and your quartiles. Basically your 5-number summary. So there's Q1 is 12, the median or Q2 is 17.75, Q3 is 20.8, and the maximum 28.1. Okay, so there's a sketch of a box plot. Okay, and then moving on to the next one, your 1-bar stats. That'll find most of these. So if you do stat, calculate the 1-bar stats on list 1. Okay, and just make sure you round correctly if I tell you to round. I didn't tell you in this one to round, so I just did to the nearest hundredth. Using correct symbols is where appropriate. That's important. This is a sample, so we have a sample mean and S, sample standard deviation. So that's 6.608. If you just said 6.6 or 6.61, that would be fine. And then X bar is your sample mean is 16.78 or 16.8 if you round to the nearest tenth. The median is 17.75. The box plot in the first part told you that. Or if you scroll down here after you do the 1-bar stats, it also gives you the 5-number summary where the median is right there at 17.75. The range is the highest value minus the lowest. So 28.1 minus 5.1, so a range of 23. And the mode is 19 and 20.5. Now, unfortunately, your 1-bar stats doesn't give you the mode, and it can be very annoying to look through this list to try to find what data value occurs more than any other. So, one thing you can do on your calculator is you can sort your list. So if you go to stat and then sort A, that means sort ascending, which means it'll sort your list from smallest to largest. Okay, and I'll just show you quickly again. The original list was how I entered them, 12.6, 6.9, 24.6, and so on in that order. Well, those are not in order from smallest to largest. So stat, sort A on second 1 for list 1. Okay, it'll say done, and then when you go into your stat and then enter, it'll have them listed in order. So 5.1 was the smallest, and then 6.9 and so on. Okay, so as you scroll through that list, what you'll notice is, you'll notice that 19 occurs more than once. That's the first number that occurs more than once. And then 20.5 also occurs more than once. So those two are the mode. Okay, number 3, the 5-number summary. We already found that, so I'm not going to say any more about that. That was from your box plot. Okay, number 4, the IQR, and then are there any outliers? Well, remember the IQR is just Q3 minus Q1. So the IQR here is 20.8 minus 12, or 8.8. So now to find if there's any outliers, that's the 1.5 times the IQR rule. So multiply 1.5 times 8.8, you get 13.2. And that is where you take Q1 and Q3, and then you add 1.5 times the IQR to Q3. So you take 20.8 and add 13.2, and that gives you 34. So outliers will be any data value larger than 34. So anybody with more than 34% body fat. And then take Q1, subtract 13.2. That gives you negative 1.2. So any data value below negative 1.2 would be an outlier. Now that one definitely is not going to happen. You're really only looking for anything greater than 34. It happens to be that none of the data values are greater than 34, so there are no outliers in this data set. Okay, and then to find the percentiles, P30 and P90, you're basically saying for P30, you're asking yourself what data value has 30% of the data values below it. So you count 30% into the 22 data values, and you get 6.6. Now this is where you round up to the 7th data value. So whatever the 7th data value is P30. And it ends up to be 12.6. Now again, you can't use the table that I gave you up here because it's not in order. You have to make sure it's in order first, which again is why I would use the ascending on the stat menu. So the 7th data value, you can see right there, L17 means you're at the 7th data value, that's 12.6. Similar for P90, you want to go 90% into the data set. That gives you 19.8 data values. So you round up to the 20th data value, and using a similar method, you get 24.6. That's the 20th data value. Okay, and then if you go backwards and ask, well, what percentile is a 15.3% body fat? You have to take the number of data values that are less than 15.3 and divide it by the number of data values. So there's 8 data values that are less than 15.3, and you divide that by 22. And you get 0.3636. So you could say approximately the 37th percentile is 15.3.